In our discussion of C's data types so far, we've laid out that there's these basic types like int, char, float, and double, and then from those types you can create a pointer to such a type, or you can create an array of such types. But the more general rule in C is that given some type in the language, you can make an array of that type, and given some type in the language, you can make a pointer of that type. And this works recursively. So we have our int type, and so we can make a pointer to an int, but pointer to int is itself a type, and so we can make a pointer to an int, or we can make an array of pointers to int. Or for example, we can create an array size 12 of ints. That itself is a type, so we can create an array of that type. We can create an array size 4 of arrays size 12 of ints. And that in turn is another type, so we can create a pointer to that type. We can create a pointer to an array size 4 of arrays size 12 of ints. And that itself is a type, so we can create an array of that type. We can create an array size 7 of pointers to arrays size 4 of arrays size 12 of ints. And that itself is a type, so we can create a pointer to that type. We can create a pointer to an array size 7 of pointers to arrays size 4 of arrays size 12 of ints. And so on ad infinitum. It's important to know that C considers the size of an array as integral to the type. So when you have two things where an array size differs, they're not really the same type, they're distinct types. So for example, if we have a pointer to an array size 4 of arrays size 12 of ints, that's a distinct type from pointer to an array size 4 of arrays size 30 of ints. And pointer to an array size 5 of arrays size 12 of ints is another distinct type. Why the fact that these are three distinct types is significant is something we'll explain shortly. Now, you're probably confused by these complex pointer and array types because it can be hard to imagine what they actually are. What do they look like in memory? Well, in the case of pointers, it's actually really simple. A pointer value, no matter what it points to, is always just a single address. So say, if you create a variable which is a pointer to char, or you create a variable which is a pointer to float, or you create a variable which is a pointer to an array size 4 of array size 12 of ints, well those are all pointers, so what they look like in memory is just they're enough space to store an address, and that's it. In terms of bits, pointers all look the same no matter what kind of thing they point to, but say if you have a pointer to a float, then it must be a pointer value which represents the address of a pointer to float somewhere in memory. It's the address of a particular kind of pointer. And say a pointer to array size 4 of array size 12 of ints, well that's a pointer value which represents the address of some array size 4 of arrays size 12 of ints somewhere in memory. It's the address of a particular kind of array. It can be a little bit trickier to picture what a complex array type looks like in memory, but the general rule is that an array is always a contiguous block in memory of some number of things, those things all of the same type. So in a simple case, an array size 7 of doubles is a contiguous block that consists of 7 doubles, one double each after the next. An array size 15 of pointers to chars, that's a contiguous block of 15 pointers. And we know what pointers look like in memory, they're just addresses, so effectively it's enough space to hold 15 consecutive addresses. Even in the case of an array of arrays, it's still the same idea. Here we have an array size 4 of x, where x is an array size 12 of ints. So if you're trying to picture what that looks like in memory, you just need to picture what an array size 12 of ints looks like, and imagine 4 of those, one after the other. So you should be able to see that an array size 4 of array size 12 of ints is going to take up the space of 48 ints, because we have 4 arrays, each one containing 12 ints. So 4 times 12 is 48. Here's a diagrammed example of an array size 4 of arrays size 3 of chars. The array is made up of 4 things one after the other, represented by the blue boxes, and each one of those blue boxes is itself an array of 3 chars, represented by the orange boxes. For another example, if we have an array size 2 of pointers to arrays size 4 of arrays size 12 of ints, well, that sounds scary, but as you can see, it's simply an array size 2 of pointers, so it's just 2 pointers. It turns out that most of the complexity in the name of this type is in describing what kind of thing the pointers point to. But the representation in memory of this type is very simple, it's just 2 pointers. One more example, if we have an array size 2 of arrays size 3 of pointers to arrays size 12 of floats, well, first of all, that's an array size 2, so we have 2 things, one after the other, represented here as red boxes, and each one of those red boxes is itself an array size 3 of pointers, here represented in green, and that's what this thing looks like. Each one of those pointers is a pointer to an array size 12 of floats, but those things are elsewhere in memory. They're not part of this array, so we don't diagram them. Once you become comfortable picturing what one of these complex types actually looks like in memory, it's still very easy to get confused because of an unfortunate quirk in English. Instead of talking about these complex types in terms of array of and pointers to, it's possible to reverse it such that when I say an array size 12 of ints, I can instead say int array size 12. Or instead of saying an array size 4 of array size 12 of ints, I can say int array size 12 array size 4. Or instead of talking about a pointer to an array size 4 of array size 12 of ints, I can call the same thing an int array size 12 array size 4 pointer. What's going on here is that in English I have a stylistic choice. Instead of connecting these words pointer, array, and int using prepositions of and to, I'm instead expressing the relationship between these words by using them as adjectives. And when I do that, I put everything in the opposite order from when I connect everything using to and of. Now, I would say that actually in practice, using these words as adjectives to connect them rather than using prepositions, that's actually more common. Practicing programmers are more likely to say an int array pointer rather than a pointer to an array of arrays of ints. I'm going to stick with the form that uses prepositions because I think it's actually clearer. But in practice, I would say you actually need to get used to using both forms. The most important thing at this point, though, is simply that you are cognizant of this issue. And what you should absolutely not do is mix the use of prepositions and these words as adjectives in one type name. So say, when talking about a pointer to an array size 4 of arrays size 12 of ints, you can legitimately also call that an int array size 12 array size 4 pointer, but I strongly recommend that you don't call it, say, a pointer to an int array or a pointer to an array of int arrays. If you start doing this, you're just adding needless confusion to what already is the most complicated concept in the whole language.